Okay, what we did before, we're going to isolate it now and do it more on just one function. So for a while, we'll just be working on the absolute value, right? You need to remember, what is the parent function? Parent function is y equals, or f of x equals the absolute value of x. What does that do? What does the absolute value do? We've talked about it like a guillotine, right? Like the thing that you drop with a knife and it just cuts some, like, well, they used to use the guillotine to chop off people's heads, right? That's the one you see in the movies and all that. Well, this one, it chops off negative signs. So if we look at this domain right here is -2, -1, 0, 1, and 2. Those are the possible x values that they're giving us to plug in. Well, if I plug that in, the absolute value chops off the negative, so the y is 2. Chops off the negative, the y is 1. That doesn't have a negative, so it just stays the same. Same thing for 1, same thing for 2. Now the range for this one, since they gave us specific values, the range is the possible y values. So I have 2, 1, 0. I don't have to repeat the 1 and the 2, right? If I look at that, I'm graphing it, right? So -2, +2, -1, +1, 0, 0, 1, 1, 2, 2. And you know this would continue like this, right? And just keep going that way and keep going that way. Okay? But since they only gave us this, that's why we gave just a specific domain and range. Now, the x-intercept, where does this cross the x-axis? The x-intercept crosses at 0, 0. Where does it cross the y-axis? Also at 0, 0. Okay? So that refreshes our memory on what the absolute value parent function is. Right here is a little deceptive because we usually have a positive or negative a in here, and then a positive or negative a in there. Now the plus or minus just means a sign change. The a tells us if it's a shrink or stretch or shrink, and the h is left or right. Positive goes left, negative goes right. The K right here is up or down. Whoops. Positive goes up, negative goes down. Okay, so we're going to keep using those rules that we used in the last test. All right. Starting out with this one. Starting out with the example number 1 right there. Sorry. If they give us just well, if they don't tell us the domain, then it's the whole thing, right? Plug it in. But this right here is a +2. So if I'm writing out mine, I'm just going to put -6, -2, 0, +2, +6. Right? Those are my x values. I'll start with these all the time. If I plug in a -6 here, -6 plus 2 is -4. The absolute value cuts off the negative and I get a +4. Okay, -2 in here. -2 plus 2 is 0. Absolute value of 0 is just 0. I put 0 in there. 0 plus 2 is 2. Right? 0 plus 2 is 2. And the absolute value of 2 is just 2. +2. 2 plus 2 is 4. And then get the absolute value of 4 is just 4. 6 plus 2 is 8. Absolute value of that is 8. So your grid only goes from 0 to 6, right? But if I start graphing this, -6, +4, -2, 0, 0, +2, 2, +4, and 6. I guess I could have done 4, right? 6 is going to be off the chart. So if I do 4, 4 plus 2 is 6. Absolute value of 6 is 6. So 4, 6. And you can see it followed the same slope the whole time. Right? Goes to the edge, that means it has an arrow at the end. Right? It can keep going. We can keep going with the numbers, but it'll keep looking like that. So what just happened to this V shape from the parent function we did up here? Right? What happened to this V shape? It moved to the left. Right? But I should know that from in here, this is H and it's positive. So just like we wrote up here, if it's a positive, it'll move to the left, and it was 2, so it was 2, so it moved to the left too. So that's my transformation. We should know the transformation before we graph it. The domain, this goes from negative infinity to infinity. That's all real numbers. Now the range is the part that's going to change quite often. If we start going up the y-axis, when am I pointing at the function? Right here. So at y equals 0 is where it starts. There's a dot there, so that's included. And the arrow points up, so that's all the way up to infinity. Okay. Same thing here. I'm just plugging in my numbers into my equation to figure it out. I'll start with negative 6, negative 2, 0, positive 2, and 6. Right? Those are my x values. If I find my y values, so I put this negative 6 in there. The absolute value makes it positive. What is 6 minus 2? It's 4. I put a negative 2 in there. The absolute value makes it positive 2. Positive 2 minus 2 is 0. Put a 0 in there, it just stays a 0. 0 minus 2 is negative 2. If I put a 2 in there, make the absolute value, it goes away. Makes it positive 2. 2 minus 2 is 0. And then 6 in there, 6 minus 2 is 4. So negative 6, positive 4, negative 2, 0, positive 2, 0, 6, 4. I missed the 0, negative 2. So notice the same slope, same looking V. Looks like this now. Going on up and up. All right, what happened to my V shape? It moved down 2 units. So down 2. Where are the intercepts? Oh, that's one thing I didn't do here on this one, the intercepts. The x-intercept is at negative 2, 0. And the y-intercept is at 0, positive 2. Okay, so on this one, the intercepts. Notice this time there's 3 of them. There's one here, and one here. So the y-intercept is at 0, negative 2. X-intercept is at negative 2, 0. And positive 2, 0. So for this type of equation, you can have up to 3 intercepts. Now domain, again, the arrow goes left and right, so that's all real numbers, or negative infinity to infinity. And then the range, I start at the bottom, I start moving up, and it starts right here at negative 2. There's a dot there, so it's included, and it goes all the way up to infinity. All right, I want you to try number 3 on your own.